Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled A Centered Clustering and Weighted Scheme to Support Mobility in WSN. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the application area that we have designed for the IoT networks, where sensors-based communication is being done and inspired from the wireless sensor networks. So before moving to the video, let's talk about what we will cover into this video. In this video, initially we will discuss in which application areas the current developed system can be implemented in the real world. Then we will talk about what code we have designed and how to execute it, which file is to be executed, and then what are the software and library requirements for it. Next to that, we will discuss what are the current systems and what are the problem identified in that, and then in order to handle those problems, what is given in the proposed method. Finally, what are the experimental results, the parameters, and what are the outcomes came out from the simulation will be discussed. So let's initially talk about the application areas. As the application is related to the sensor-based networks or for the IoT, there are certain options available. So you can see when it was only restricted to the WSN, then there are certain applications like for the energy control grid, environmental monitoring at the remote locations, for the precise agriculture, for the transportation, smart city, healthcare applications where body area networks are there, in which the health is monitored using the sensors, industrial application where easily the human interference is restricted. In the another picture you can see, which was created by the 101blockchain.com, it is for the smart cities, retail IoT applications, as currently Amazon and many other are approaching toward the sensor based stock checking, like as per the user is purchasing things, automatically getting the billings and all that stuff. Smart manufacturing, tourism and hospitality. So there are even the fitness based wearable devices. All those are inspired from the sensor network. These sensors are restricted to many of the things like their battery basically. So in order to handle that issue, this domain is being becoming popular for the researchers to work on, so that batteries constraint can be handled and lifetime can be extended, because as much battery will be stay longer, more will be reliable the solution. So the code that we have designed, you will get this folder under which we have whole code files and the result files in it. All these files are the result file generated, so you can also delete and regenerate them, but right now as I'm showing you the demonstration, so these are already saved results. I will show you that how it has saved. In order to run this, you must have the MATLAB software with you. The MATLAB software that we are using for the simulation is MATLAB 2019A. You can use MATLAB 2018 or above, but make sure it should be the full version, not the trial version, because certain libraries are not available in the trial version. So in order to run this code, you just need to go to the main folder where the code is placed, and you just need to copy the file. Take care of the thing, like you need not to copy path here, you just need to go to the folder where the files are placed. So copy this path and then go to the MATLAB and paste it. When you will press enter, you can see all the files are available here. So out of this, there are certain scenarios that we have designed. So this is the main code that we have designed, and these are the files those we considered from the base paper and did the comparison at the by varying the different parameters. So now in order to run this code, you just need to select the file, and here you can see a run button, and you just need to click not on this arrow one, because it will give you a certain option to run. So avoid this, just click on the upper play button and you can start running the system. So this is how you can run the code. I'm running the code. As you can see here, we have written the whole code, and represented the results in terms of the different parameters. So I'm running this code. When I'm running this code, you can see it will show me the processing in a very fast process, because it totally depends upon your resources. As it is running, let's talk about that what exactly the current system. So we were referring this paper with us, in which the energy efficient routing algorithm was designed for the wireless sensor network. Wireless sensor network is currently used in the IoT network. So what they have done, they have implemented one cluster head selection methodology on the basis of the weight, where they are considering the parameter like distance and the energy only. So these two parameters, distance to the sink and energy of the node, these two factors are considered for the cluster head selection. Secondly, clustering is done on the basis of the chances only, which is a very traditional way to select the cluster head, clustering protocol. So in as the clusters will be effective, the effective will be the system. So as the system will be good, it will be more stable. So in order to avoid the issues those were faced into this, one of the advancement that we have done is like the cluster formation is not on the random or the fixed basis. It is on the basis of the fuzzy C mean clustering technique, which is a data mining technique also, because it get the points and see where the group of the information is there, and they form the clusters for it. Secondly, we have extended the cluster head selection method, not restricted to the residual energy and distance to the sink, but we have added one more parameter, that is the distance of nodes within the cluster to the cluster head, because only cluster head to sink communication is not important, but the other node in the network, those are transferring their data to their cluster head, is also important. So we have considered these three factors, and the overall fitness is to be reduced, right? So what we are doing, let's see, these are the results that we have achieved. We will talk about it later. So in this code, initially we have defined the energy parameters. Those are the energy model for the communication in the wireless. Then the configuration that the paper is using, we are following that. And initially the circular network has been drawn. Then this factors gives us the information that how many cluster count it is required, because the simulation that they have done at the end is doing the analysis by varying different factors. Like you can see, this is the normal model, and then by changing the factors, like they are changing the radius of the mobile sync, communication range of the mobile sync, then they were changing uh, the area, it is of 100 by 100, 200 by 200, 300, 400. So by changing the total area of the network, they are calculating it. Then they changes the count of the weight, given that how much weightage should be there with the nodes, and then number of clusters, how many clusters can be there, they choose 3, 4, 5, 6 and 7. So obviously, in order to defend our possibility, so we need to do all the scenarios with them. And finally, they have also changed the mobility speed of the sync, because the system is for the mobile sync networks. So keeping these things into mind, the one of the scenario we have designed, in which we have took these static scenarios, in which those are the initial outcomes came out from it. This is the scenario where they have considered the parameters like energy, distance and all. So following that, initial energy is 0.5 joule, area and number of nodes to be clustered is 0.5. It means 5 clusters can be there, and the speed of the sync will be 20, uh, and the communication range is 0.75% of the radius. So these are the factor which is for the case 1. So while considering this, we have did the comparison, and you can see the outcomes are there with us. So the results are already drawn out. So this was the network that we have designed. These red colors is the motion of the sync during the whole simulation. So it is representing in which section the sync is revolving. And these colors, blue color is one of the cluster, green is one of the color, red is the one of the color, black is one of the cluster, pink is one of the cluster. So similar color represent the combined cluster and the nodes within that cluster. So after the simulation, we got the results in terms of the dead nodes, alive nodes, energy. This is the graph of the live nodes with respect to a traditional model, which is a base paper, and this is the energy consumption. So other than that, this is one of the scenario which is the basic one. Other than that, they have changed the area. So what we did in the code, we are getting the input from the user that how much area should be there. So accordingly the points will be generated and rest of the simulation will be done. And finally, by using the save command, we have saved the results. You can see all these files, that area 100, and then 125, 150, 175, 100, then area of 100, 0, 125, because this was the scenario in which the area was moving. Area is changing here, area is changing, and the communication range is also 0.0, 0.25, 0.5, 0.75, and 1. So these scenarios has been saved into this. For area is equal to 100 and 0.05, it is basically the here radius of the sink, means communication range of the sink. So this is how we have done it for changing the area. Then count of the clusters. So clusters are being calculated here, where we are giving the ng factor. So which was static in the previous scenario, here the cluster count is changing, and accordingly FCM is giving us the cluster centers to form the clusters. In the next scenario, we are changing the communication range only for the radius. So here you can see only the radius is getting input, rest all the scenarios are static as per the base papers scenario. Finally, the speed of the movement of the sink is given, in which this is the factor which was initially 20 in every of the scenario. Here you can see that it is 20 and so on. Here this speed is being changed because this is given that at what specific point the sink will move for the next round. So after running all these codes, you can see if I'm running this one, it will ask me that what will be the area. Let's say I'm entering the area to be the 100 and communication range to be like 0.25. So it will reprocess it and will show me the simulation over here once all the simulation will be done. So after the simulation will be done, the results will be represented, and we have already saved them in this because we are shorter with the video and we are not able to run every scenario right now. So we have saved the results. You can just delete these files and can get the results also. So you can see here the first node dead was around this, and this is the range of the movement of the node sink, because we were giving the radius of the movement of the sink, so it is less, which was earlier the outer boundary, right? So this is how we have saved all the results. And finally the comparison files were also given, those are loading these files. So these are the code files for saving the results, and these are after saving all the scenarios you can get the results in a single file. So this is the file that is giving the comparison by loading those files. So when I'm running this, you can see we will get the outcomes as per the base paper, and did the comparison with them to show that our system is effective. So here you can see by changing the r and the range, with the radius of 0.25 of r, 0.5 of r, 0.75 of r, and 100% of r at a radius of 100, right, r100. Then this is for 200, this is for 300 and 400. So these are the results. So you can see this is the analytical study. In every of the scenario, the results are varying, so analytical outcomes can be shown. Same for the cluster variation result analysis. So you can run to save the results, and this is the comparison code for getting the results from the variation in the cluster count for the 3, 4, 5, 6 and 7. So you can see as the cluster count is increasing, the lifetime is also increasing. This is how the analysis can be done. This is for the radius, this is for speed, and so on. So further modifications are still possible because a lot of possibilities are there with the network architectures, with the IoT networks. So for that information you can contact us directly and can get the information. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.